Welcome to this lesson on data analysis and drawing conclusions. The LANTITE frequently presents you with graphs, tables, and data sets, and asks you to interpret them, spot trends, make predictions, and importantly think critically about what the data actually shows. This lesson will build your skills in all of those areas. By the end of this lesson, you will be able to identify trends in graphs and tables, make sensible predictions, compare data sets, draw valid conclusions, and recognize when claims go beyond what the data supports. These critical thinking skills are essential for the LANTITE and for your work as a future teacher. A trend is the general direction data moves in over time. There are four main types. Increasing values rise over time. Decreasing values fall. Stable values stay roughly the same. And fluctuating values bounce up and down without a clear direction. On the LANTITE, you will be asked to describe what is happening in a graph. Focus on the overall pattern, not individual data points. Let's look at an example. The percentage of Year 3 students meeting the reading benchmark went from 89% in 2019, dipped to 85% in 2020, then rose to 91, 93, and 95%. The overall trend is increasing, even though there was a dip in 2020. On the LANTITE, do not get distracted by one anomalous data point. Look at the overall direction. Now let's make a prediction. Sandwich sales are increasing: 120, 135, 148, 162, 175. The average increase per week is 175 minus 120, divided by 4 weeks of change, which is about 14 sandwiches per week. So a reasonable prediction for week 6 is 175 plus 14, which is 189 sandwiches. But remember, predictions assume the current trend continues. The further ahead you predict, the less reliable it becomes. The LANTITE may ask you to predict the next value, or to explain why a prediction might not be accurate. When comparing data sets, look at both the center and the spread. School A has a mean of 485 and a range of 290. School B has a mean of 490 and a range of only 140. School B is slightly better on average and much more consistent. On the LANTITE, comparing data sets usually means discussing both the average and the spread. You need both to make a fair comparison. This is one of the most important critical thinking skills for the LANTITE. Correlation means two things happen together. When one goes up, the other tends to go up too. Causation means one thing actually causes the other. The critical rule is that correlation does not prove causation. Just because students who eat breakfast tend to score higher does not mean breakfast causes better scores. There could be a third factor, like a supportive home environment, that leads to both regular breakfast and better study habits. Data can be manipulated to tell whatever story someone wants. Watch for truncated axes. When the y-axis does not start at 0, a small change can look enormous. Cherry-picked timeframes show only the data that supports a claim. Misleading scales use uneven intervals. And small sample sizes can produce dramatic-sounding percentages. 80% sounds impressive until you find out it was 4 out of 5 people. On the LANTITE, you may be asked to explain why a particular graph or statistic is misleading. Let's evaluate a claim from a news article. It says schools with tablets have 15% higher scores. Therefore, tablets improve learning. Is this valid? No, this is correlation, not causation. Schools that can afford tablets may also have better funding, smaller classes, and more experienced teachers. We also do not know the sample size or whether the study controlled for other variables. On the LANTITE, when asked to evaluate a claim, check for these issues. Is it correlation or causation? What is the sample size? And are there other possible explanations? Here is an example of insufficient data. A principal surveys 8 parents at an assembly and claims 87.5% of the school community supports longer hours. There are 3 problems. The sample size is far too small. The sample is biased because parents who attend assemblies are likely more engaged. And the conclusion extends to the whole school community, but only parents were surveyed. On the LANTITE, look for these red flags: tiny samples, bias samples, and conclusions that go beyond who is actually surveyed. Here are the common mistakes to watch for. First, confusing correlation with causation. Just because 2 things happen together does not mean one causes the other. Second, ignoring sample size percentages are meaningless without knowing how many people were surveyed. Third, focusing on one data point instead of the overall trend, one outlier, does not define the pattern. Fourth, accepting a graph at face value without checking the axes and scales. Pause the video and try these 6 problems. Problem 1 asks you to identify a trend. Problem 2 asks you to make a prediction. Problem 3 is about comparing 2 datasets. Problem 4 tests whether you can distinguish correlation from causation. Problem 5 asks you to evaluate a claim based on a small sample. Problem 6 asks you to identify what is misleading about a graph. Check your answers when you are ready. Let's recap. To identify trends, look at the overall direction, not individual points. Predictions extend the trend, but get less reliable over time. When comparing datasets, look at both the average and the spread. Remember that correlation does not equal causation. Watch for misleading graphs with truncated axes or cherry-picked timeframes. And always check sample sizes before accepting any claim. On the LANTITE, these critical thinking skills come up often. Practice questioning the data, not just reading it.